Hi, I'm Rob, and I'd like to welcome you to this development environment configuration video in the AI engineering hands-on playlist on the Cumulus Cycles channel. In this video, we'll install tools and frameworks that we'll use throughout the videos in the playlist. However, before we get started, I want to mention that I'm working on a Mac Studio with an M1 Max chip, 10-core CPU, 32-core GPU, and 64 gig of RAM. I mention this for a couple reasons. First, the software installation process in this video will obviously be for a Mac. So if you're installing on a different operating system, your steps will vary. And second, depending on your hardware, your performance when running models locally will most likely vary compared to my system. But at least you'll have some performance reference based on my setup. Okay, with all that out of the way, let's get started. Now, since I'm working on a Mac, I have Homebrew installed. So I've used that for a number of installations. However, you can always download software from the web and install it as with any other program. But I highly recommend considering Brew if you're not already using it. So first and foremost, you should have Python installed. I'm going to assume you already have it, or you probably wouldn't be here. However, if you're not sure, you can open a terminal and run python -- version to see if it's installed. And if you don't have it installed, you can head over to the Python download page or use Brew to install it. Next, I just want to mention that I'll be using Cursor for my IDE. It's a fork of VS Code with an integrated LLM for coding, but feel free to use whichever IDE you're most comfortable with. Now, the first tool we'll install is the UV Python Package Manager. If I jump into a terminal and run UV version, you'll see I currently have it installed. But if you don't yet have UV installed, head on over to the installation page and follow the steps for your operating system. Next, I'm going to execute the UV Python list command to show which versions of Python I have available to UV, which we can see I have a few. But if this is your first time running UV, you can execute the UV Python install command, passing it the version of Python you want to have accessible to UV when creating virtual environments. Here we see I already have Python 3.12 installed, and to get the specific version, I can execute the UV run command, passing it Python 3.12 and getting the version, which we see is Python 3.12.7. Now I'm going to go ahead and just make a demo directory we can work in and change into that directory. And if I do an ls, we see I currently don't have any files. So I'll execute the UVVN command, passing it the version of Python I want to use in this virtual environment. And if we do an ls again, we can see I now have a .vm folder. Now I'll go ahead and execute the source command, passing it the path to activate, which is in the .vm/bin folder. And if we look over to the right of my terminal, we can see I've activated the UV demo virtual environment. Now in this environment, I'll do a UV pip list, and we can see I don't yet have any libraries installed. So I'll go ahead and run UV pip install, passing it Jupyter Lab. And if we do UV pip list again, we can see we have libraries. Next, I'll go ahead and execute the UV run command, passing it Jupyter and Jupyter Lab. And we see we have Jupyter Lab running locally in our UV virtual environment. So I'll jump back over to the terminal, Control-C, say yes to shut down the Jupyter server, and then execute the deactivate command to deactivate the UV demo virtual environment. Next, we'll move on and install Ollama, which will allow us to run models locally. I already have Ollama installed, but what you'll want to do is head over to the Ollama download page, then download and install for your operating system. Once installed, we can head over to a terminal and execute the Ollama list command. And we see I don't yet have any models pulled. So what I want to do is pull the Llama 3.23 billion model, which we could do in a terminal by executing the Ollama pull command, passing it Llama 3.2:3b to pull the model. And if we do an Ollama list again, we'll see the model's been pulled. And to test this, I'll execute an Ollama run, passing it the name of the model, and then send a message of who are you, and we see the response from the model. Now, instead of interacting with the Llama model directly in the terminal using the Ollama run command, I'll make a call to the endpoint on the running Ollama server. And since we've already executed a few Ollama commands, the server is up and running, which we can tell by executing the pgrep Ollama command. However, if for some reason your server isn't started, you can execute the Ollama serve command, which will start the server. And here we see I have an error because Ollama is already running. Now, what I'm going to do is jump into Postman, and I'm going to make an HTTP GET request to localhost 11434. And if I send this request, we see the response, Ollama is running. But in order to make a request to the API that we want to use to generate a response to our user prompt, we need to do a post. So if I change this to a post request and click send, we get a 405 response saying this method is not allowed. And that's because we need to use a different endpoint. So here, I'm going to make a post request to localhost 11434/API/generate. And before I do that, I want to check the headers and ensure the content type is set to application JSON. And in the body, I'll select raw with the type of JSON, and I'll pass it an object specifying the model, which is Llama 3.23b. The prompt is who are you, and the stream will be set to false. And we'll see more on stream later in the videos in the playlist. But for now, let's go ahead and send a request. And we get our response from the model running locally on Ollama. And that brings me to the next piece of software we want to install, which is Postman, which we'll be using to test our applications throughout the playlist. So head over to the Postman site and download and install the version for your OS. And for the last part of this video, we'll work with the OpenAI API. And to do this, you'll have to create an OpenAI account, which you can do by heading over to their website and signing up. And then after you sign up and log in, click the gear icon, which will bring you to your settings, and then select API keys. Here we can see I already have an API key, but I could create a new secret key. And you can select your default project and then create the secret key. The key has been generated, so go ahead and copy this and save it off in a safe place. Now, I don't actually need this key, so I'm going to go ahead and delete it and jump into a terminal. And from here, I'll reactivate the virtual environment in my UV demo folder and launch Cursor. And in the file viewer pane, we see we have our VN folder. Now I'm going to go ahead and close this chat and create a new file in the root named .env. And in this file, we want to have one entry where the key name is going to be OpenAI_API_key, exactly like that, equals, and then replace this text with the API key you copied from OpenAI. Now I'm going to go ahead and do this off camera because I don't want to reveal my key, but it's important to remember that if you're working in a GitHub repo, make sure to add the .env file to your git ignore because you don't want to expose this API key. Now I've added my API key and saved the file, and the next thing we want to do is create a requirements.txt file. And we're going to add the libraries for Jupyter Lab, Ollama, OpenAPI, and Python.env. So go ahead and save the file. Now with the file saved, I'm going to go ahead and open a new terminal. And we see we're in our UV_demo virtual environment. And I'll execute the UV pip install -r command, passing the requirements.txt file. And our libraries are now installed. And now I'm going to go ahead and create a new file. Named OpenAI_demo.ipynb, which is a Jupyter Notebook file. Add a code cell, and I'm not sure why that's text, but let's change it to Python. And then add the import statements for .env and OpenAPI. And we'll go ahead and execute this cell and select the VN kernel. And with the imports done, we'll call load.env and then instantiate an instance of the OpenAPI client. Then we'll create a response variable, setting it equal to the value of calling client.chat.completions.create, which is the OpenAI Create API, setting the model to GPT-3.5 Turbo, and the message equal to a list with two dictionaries. The first is a role set to user, and the second is the content with the message, who are you? Then after executing that, we'll print the content of the response. Now, one thing to know about using the OpenAI APIs is that they have a pay-as-you-go model. So in order to make API calls, you need to have a balance on your account. And you could do that by going to billing and then add to credit balance. The minimum balance you can add is $5, which I did when I created this account. And I've made a number of API calls, and you can see I still have $4.96 left. So although this will cost you a little bit of money to get started with, unless you're running a lot of API calls, this will last you for a while. So let's go ahead and execute this cell. And we can see the response from calling the OpenAI model. Now let's create another file named olama_demo.ipymb. And first, let's jump back into the terminal and make sure the Olama server is running, which we see it is. Then we'll create a new code cell and import Olama. Select the kernel. Then we'll call Olama chat, specifying the model, which is the Llama 3.23b model, which we pulled earlier, creating a message, setting the role to user, and the content, who are you? Then we'll print the message's content from the response. I'll execute the cell, and we see the result. So that concludes this video on configuring your development environment for following along with the videos in the playlist. We'll add a few more tools later, like Node.js, Next.js, and Postgres and Mongo databases, but it will be a while before we get there. Until then, I hope you found this video useful, and I'll see you in the next video. Thanks for watching.